Hey guys, it's Chelsea again. So we just went over our acid-base reaction, so let's actually put that to use. Let's figure out why do we need to know how to write these reactions, right? Okay, so we're gonna read this one. So it's gonna say, what concentration of 20 milliliter barium hydroxide is needed to neutralize 15 milliliters of hydrochloric acid with a concentration of 1 molar? So to me, I feel like this is a lot to take in, right? It's just a lot of information thrown at you. But what I always like to realize is we need to see exactly what's going on in these reactions, like what's actually happening in this beaker, right? So we can see that based on our actual equation, right? So let's write this down. So we have barium hydroxide, right? So kind of in case you guys are a little stuck on how to do this, how to write the reaction, we're going to say, okay, well, barium hydroxide is barium 2 plus according to the periodic table, and then OH minus, right? Hydroxide. So let's just do the crisscross method, and then we're going to find that this is BaOH2. So barium hydroxide. And then we're going to say, okay, what's our next thing? And then, so we see it's reacting with hydrochloric acid, right? So we have, well, hydrochloric acid. So basically that hydro, you know that there's your H in there. And then your chloric acid, you know that that's not chlorate, but it's Cl, right? So you would have HCl, and that would be plus, minus. So it's just a 1-to-1. So if you do the butterfly method, you see that this is HCl. So now that we're looking at our reactants, we're going to say, okay, well, I notice that this is a base and this is an acid. So we know that this is an acid-base reaction. So of course, let's do the same thing that we did before. So let's break it apart. And we're going to say this is Ba2 plus and OH minus, right? And then same thing over here. This is going to be H plus and Cl minus. So of course, whenever we're doing these reactions, we're going to say, okay, well, they're going to switch partners. So our cation is going to go with our other anion. So that's going to be BaCl2. Don't forget to do the crisscross method, right? Or the butterfly method, sorry. And then your cation goes with your other anion. So that's going to be your water. So you have water and a salt, which is exactly what we know for these reactions. Okay, so now that we have our reaction, our next step always is to figure out, okay, is this thing balanced? So let's look at that. So we're going to say, okay, on the left side, I have 1 barium. On the right side, I have 1. So that's good. I have 1 chloride on the left, and I have 2 on the right. So I'm going to say, okay, well, there's a problem here. So in order to fix it on the other side, we know that we're just going to put our coefficient, of 2. So, okay, we have that 2 coefficient, which now we changed our hydrogen count. If you guys can see, we changed our hydrogen count. So we're going to have now a total of 4 hydrogens. Because you need to distribute in that 2, remember. And then, so, okay, so we have 4 hydrogens and only 2 on the right. So we're going to put that coefficient of 2. And then we're going to see, okay, well, that changed our oxygen count now. So we have our 2 oxygens. So we're going to look on the left and we see, okay, well, if I distribute in that 2, then that means I have 2 oxygens, which means it's balanced. So this is your final balance equation. Okay, so we have our equation written down, right? So we're going to say, okay, well, now let's write down what we actually know. So we know that we have a concentration of 20 milliliters, right? So if I'm going from liters to milliliters, I'm going to move my decimal 3 times to the right, right? And then if I'm going from, here, let me write it first this way. This is kind of a little shortcut that I found out. If I'm going from milliliters to liters, I'm going to move my decimal 3 times to the left, right? So in this case, we're going from milliliters to liters, so I'm going to move my decimal 3 times to the left. So that means I have 0.020 liters. We could have also done it in the sense where we go 20 milliliters and then 1 milliliter and then 1 times 10 to the negative 3 liters. We could have done that too, but this is just a little shortcut that I figured out works every time. Okay, so now we're going to look at it and we say, okay, well, now we have our 15 milliliters of hydrochloric acid, right? So I'm just going to move that decimal 3 times to the left. So that means I have 0.015 liters. And then we have hydrochloric acid with a concentration of 1 molar. So I'm going to say, okay, this is 1 molar. Okay, so I'm going to say, okay, well, what's my next step? So I'm going to look at another thing that we know, which is molarity, right? That's from our past module. So I'm going to say, okay, well, molarity we know is moles over liter. I have this value because that's this one. And I have this value, that's this one. So I can find my mole value. So that's exactly what we're going to do first. It's the next thing we know how to do, so that's what we're going to do. So we're going to say, okay, I have 1.0 molar hydrochloric acid. We're going to find our mole value per 0.015 liters. So we're just going to find that this equals 0.015 moles of hydrochloric acid, which this is important. Remember, we're working with hydrochloric acid. So in the end, we want to know the concentration of barium hydroxide, right? Which means that we need to work with barium hydroxide. Right now, though, we're working with hydrochloric acid. So we need to compare hydrochloric acid to barium hydroxide, right? Which means that we need to do the molar ratio. So let's do that. So we're going to say, okay, we have 0.015 moles of HCl, right? And I'm going to say, okay, well, how much barium hydroxide would that be? So I'm going to say, okay, well, for every 2 moles of hydrochloric acid, I have 1 mole of barium hydroxide. And I got those numbers from the coefficient. So I got 2 moles of HCl and 1 mole of barium hydroxide. So if you were to divide this together, you would find that this is 0.0075 moles of barium hydroxide. Okay, so we have moles of barium hydroxide, but they're asking for our concentration. So we look back at our molarity problem, we know, okay, well, our concentration is molarity, right? That's a form of saying, oh, I have a concentration of blah, blah, blah. It also means I have a molarity of blah, 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 right? So we're going to say, okay, well, for barium hydroxide, we now know our mole value, and we've known our liter value, right? So that means I can find my concentration now. That's good. So I'm going to say, okay, well, I have 0.0075 moles per every 0.020 liters, which means that my final concentration for barium hydroxide is 0.375 molar barium hydroxide. So this would be my final answer. What I do want to point out though is imagine if we were to be doing M1V1 is equal to M2V2. We would have just plugged in these values here, right? This one and then these two. But the thing is that we would have never used the molar ratio. The M1V1 never actually takes into account the fact that it could be a 1 to 2 ratio or a 2 to 3 ratio of whatever you're talking about, right? So we just need to keep in mind that this formula only works if everything is in a 1 to 1 ratio, which I like to tell my students, don't even confuse yourselves with this stuff. Always do it the long way so you can see, okay, am I doing this right? And making sure you're not missing out on that molar ratio. So I'll see you guys again for redox chemistry. I hope this helped.